All righty, here comes that important message again. The following Zoom session, excuse me, is being recorded and will appear later today on my YouTube channel, Math with Mayo. There are two different classes that may be observing this session. Therefore, when you participate in the Zoom meeting, if you do not wish for your picture or your name to be made public, please leave the video off and use an alias name. If you have questions during the meeting but not wish to speak, email me at bmail@ybcc.edu and I'll respond as soon as I can. All right, so this morning, we're going to take a look at the last objective in this unit or chapter, 4B.3. And then tonight's homework is to complete that assignment as well as the chapter review. Tomorrow, we will review during class. And then Wednesday, there'll be no class meeting. You'll take your objective 4 test. I will be available Wednesday afternoon for an office hour, but there'll be no class meeting Wednesday. You just need to complete your test by Wednesday night at 11:59 p.m. All right, without further ado, let's go ahead and get started. And so let's take a look at question number 1 from WAMAP. It says, in a small community, soccer is the fastest growing summer sport. The number of people involved in soccer in hundreds from the years 2002 to 2013 is given by the equation y equals 0.3x plus 11, where x is the number of years after 2002. All right, so we've got a bunch of important information here. First of all, let's see here. We've got the equation y equals 0.3x plus 11. It says the number of people involved in soccer in hundreds from the years 2002 to 2013 is given by this equation. So y equals number of people in hundreds involved in soccer, okay? But the key there is in hundreds. And then it says from the years 2002 to 2013, where x is the number of years after 2002. So x equals number of years after 2002. All right, so let's see what that means for us. Well, for instance, look at the equation, y equals 0.3x plus 11. So in the beginning of this problem, there are 11 of something, but that 11 is in hundreds. So that 11 actually means 1100, ultimately. Also, x is the number of years after 2002. So when x equals 0, the year is 2002. X would equal 1 in the year 2003. X would equal 2 in the year 2004, et cetera, okay? So we've got to take into consideration all of this information. It says, part A, use the equation above to complete the following ordered pair, 6 comma something. So the 6 is going to go in the place of the x. We're going to get y equals 0.3 times 6 plus 11. 0.3 times 6 is 1.8, and that plus 11 would be what? 12.8. So that's going to go up here. So our ordered pair is 6 comma 12.8. Okay, so right here we're going to put in 12.8. Any questions about that? All right. It says, write a sentence explaining the meaning of the answer in part A. Well, first of all, the 6, that's the x value, right? And x is the number of years after 2002. So 6 years after 2002 would be what year? That would be 2008. Okay. So in 2008, there were how many people involved in soccer? Well, there were 12.8, but this is in hundreds. So 12.800, you'd move the decimal point over, what, 2 places, and you'd have 1,280. So there were, let's put that in, 1,280 people involved in soccer. Okay. So let's check our work so far. That's correct. That's correct. We're good to go on. Again, any questions where I got that information? All right. If this equation continues to be valid, in other words, if this information is consistent, if it continues to increase according to this equation, there will be how many people involved in soccer in 2016? Well, 2016 is how many years after 2002? 14 years. Let's see here. Hang on a second. If this equation continues, there will be, right. So what are we using for X? X is going to be 14 because 2016 would be 14 years after 2002. So it's like the world starts in 2002 for this problem. Everything goes from there. That's sort of, year zero, or so to speak. Okay, so if we put 14 in, y equals 0.3 times 14 plus 11. Let's see, 0.3 times 14 would be what, 4.2, plus 11 would be 15.2. So there will be 15.2 people involved? No, 15.2 times 100, right? Because this is in hundreds. So we'd have 1,000, get the mouse here, 1,520, which should be that answer right there. Okay. So any questions about this problem? Again, keep in mind, this information over here is very important. You can't just skim through the problem. You've got to pick on things like that the output is in hundreds and the input is in years after 2002. Okay. Are we good to go with this problem? Any questions, discussion before we go on to another example? Okay. We're going to go down to problem number 4. It says a phone company charges for service according to the formula C of N, can't read that N very well, equals 28 plus 0.06 N, where N is the number of minutes talked. So N equals number of minutes talked. And C of N is the monthly charge in dollars. Monthly charge in dollars. C of N is a special notation. Basically, just think of it as C. C is a function of N, but we're not going to get into that right now. So your variables, your ordered pairs are in the form of N, C of N. So the input is the number of minutes talked. The output is the cost in dollars. Okay. Now, I'm going to take this equation and I'm going to write it in slope-intercept form. So I'm going to put the variable term first. So now this would be the slope, and this would be the y-intercept. Technically the C of n intercept, but the vertical intercept, okay? Again, any questions so far? So the slope of the equation is that. Now, we could write that as 0.06. And I'm curious whether that's what they did. That's what they did. We also could have written it as a fraction. This would be what, 6 over 100, which would reduce to what, 3 over 6. Wait, 6 over 100 would be 3/50ths, I guess. So you could also put 3/50ths in there, but it's written as a decimal, so that's the slope, okay? Now, the slope's units are, let's go through and let's look at what all the units are, all right? C of n, that's in dollars. So that means this whole thing has to be ultimately in dollars, okay? So we've got C of n dollars equals 0.06 n plus 28. Well, 28 would have to be in dollars. Let's see. N is minutes, right? So this is minutes. Minutes. But the question is, what are the units for the slope? I've got to end up with dollars. This is dollars, but this is whatever this is times minutes. Well, if the slope was in dollars per minute, and then this was times in minutes, wouldn't the units of minutes cross out and we'd have dollars left over? So we've got dollars equals dollars plus dollars. Are you seeing how that worked out? So our slope, the rate, has to be in dollars per minute. Question? Okay. All right, so there's our dollars per minute, okay? The vertical intercept in this equation is, so the vertical intercept, why are they calling it the vertical intercept instead of the y-intercept? Because technically we're not using x and y, we're using n and c. So you might say the c of n intercept, but the vertical intercept of this equation is what? It would be the 28, right? Or over here, the 28. Oops. So here we've got 28. Okay. And there's your 28. Any questions about this particular example? Are we good to go on to another example yet, or still, Mike, you still looking at some stuff there? Are you good?
I'm all right. I'm just watching my daughter at the same time. That's why I look so perplexed.
Okay. All right. I understand. All right.
All right.
Sounds good. Okay. Well, let's go on to another example. And let's take a look at number 7. Superman is swooping down to save Lois, that would be Lois Lane, at a rate of 2 miles per second. He starts 21 miles from her. Write an equation in slope-intercept form to model the situation where d is the distance from Lois and x is the time in seconds. And we see that our equation is going to be written in the form of d equals something, all right? So d equals distance from Lois and x equals time in seconds. All right. We know that Superman is swooping down at a rate of 2 miles per second. So there's your rate of change, your slope. So I'm just going to say 2. And he starts 21 miles from her. Starts 21 miles from her. Well, let's see. D is the output over here, okay? So at the beginning of the problem, he's 21 miles from her. So 21 miles would be what? The vertical intercept. So
yeah,
right there. And then what's the rate of change? Well, I wrote a 2 here, but let's look at this. He's starting 21 miles away from her, right? And he wants to swoop down and save her. So he wants to get closer to her, which means the number of miles away from her is going to decrease. So our rate or slope is going to be negative. You follow that? So that he's going from here down to where finally he rescues Lois. So that means our equation is going to be D equals negative 2x plus 21. So there's our negative 2x plus 21. Everybody understand why the slope is negative? Because it,
yeah.
All right. Now graph your equation. Well, again, we know that the slope is negative 2 and the vertical intercept is 21. So we're going to start at 21 and then we're going to go down 2 and over 1. Notice I went from 21 down to 19, right? And then over 1. So let's see if that checks out right. It does. Okay. So again, I graphed a line. I stuck with just 2 points, the y-intercept, or in this case, the vertical intercept, and then applying the slope down 2 and over 1. But our scale was different on this axis than this axis, wasn't it? So we have to be really careful with that. We okay with this? Any questions there? All right, let's go on then to number 10. A town's population has been growing linearly. In other words, according to a fairly straight line. Okay, so in other words, if we plot the information, it should form a fairly straight line. In 2003, the population was 51,000. And the population has been growing by 2,200 people each year. Write an equation for the population X years after 2003. So that means X equals 0 in the year 2003. Okay. So when X is 0, it's 2003. What is P?
51,000.
51,000. Excellent. So that 51,000 is our starting value. That is to say, our vertical intercept. And what's the slope or the rate of change?
2,200.
Yeah, 2,200. Now, notice this one This number is straightforward. It's not like it's in hundreds or something. It's the actual number. But the X value is time after 2003. Okay. So P equals, let's see, our would be 2200 times X plus 51,000. Our starting value is 51,000, and it's growing at a rate of 22,000 per year. 2,200 per year, sorry. So we're gonna have 2,200 and then X plus 51,000. Okay. Let's check it there. There we go. Any questions about this example? So again, in this case, X was different from the year, but the P value or Y, the output, was as given. So you've got to really pay attention to details. I had a student several years ago who was taking an English class at the same time as my math class, and their teacher had been teaching them how to read by sort of skimming information. And that's, I'm out of focus here, aren't I? And that's all fine and dandy when you're trying to read a story. But in a math story problem, every word may be critical. So don't just skim the problem. You may have to read it 3 or 4 times to extract all the information that you want. Okay, let's see here. Next on my list, we're going down to 18. Okay. Why am I so out of focus today? I'm trying to see if I can get this to focus on me there. Maybe it's just because it's Monday and I'm just out of focus. That's just the way it is. All right. Number 18. A plumber charges a flat fee of $90 to show up at a customer's house, plus an additional $65 an hour. Create a linear equation to represent the amount of money the plumber makes for any number of hours he spends at a customer's house. Define the variables. X is the number of hours. And Y is amount of money charged. And let's see. It looks like money is in dollars here and here. So I'm going to say amount of money charged in dollars. Okay. I want to talk about something called fixed cost and variable cost. Just for a moment, fixed cost is like it's a one-time charge. Variable cost varies depending on how much of something you do. So like in this case, the $90 would be the fixed cost. That's the flat fee. That's a one-time fee. The $65 is a variable cost. It varies depending on how many hours there are. So your fixed cost or your vertical intercept would be the $90, and your variable cost would be the $65 per hour. So that would be your rate of change or your slope. So our equation is going to be Y equals 65x plus 90. So we would start at $90. That's a one-time fee. And then the price goes up $65 for every hour that the plumber is at the person's house. Okay. So let's see here. We've got Y equals 65x plus 90. Yeah, okay. Any questions on that? Determine how much the plumber how much should be how much the plumber makes. Oh, well, I guess we're not here for the English lesson. After working for 8 hours at a customer's house. So what would we do to get that answer that goes right here? Anybody?
Plug in
65 times 8.
Okay, I heard you, Eric, and let's see, where did Courtney? That's what I think you were saying as well, right? Yeah.
Yeah, 8 is x.
So 65 times 8 plus 90. And let's see on our handy dandy calculator, 65 times 8 is 520 plus 90 is 610. And notice they already have the units, so we don't need to put them in. Okay. And again, you got to be careful because I'm curious what's going to happen if I put a $sign in there, if it'll accept it. Let's see what happens. It doesn't like it, does it? Oh, I'm going to go ahead and submit it. Huh. It said it was okay, so that's kind of weird. But it said it didn't like it initially. So I was hoping it would actually reject it, but it didn't. My point being, you know, pay attention to the units. If they're included, you shouldn't need to put them in there. If they aren't, you should need to. All right, we okay with that? All right, I just want to talk a little bit about graphs and formulas and whatnot. And for that, let's see, let's go back to, which one was it? Okay. No, that wasn't it. Trying to find the one that okay. Sorry about this. Okay, number 1. Oh, I guess it was number 1. I didn't think it was back that far. Yeah, number 1. So this whole idea about how the variables didn't represent just a specific number like 1 or 7 or 12. For instance, the number of people was in hundreds and X was the number of years after 2002. Why do they do that? Well, one of the reasons, let's say that we were going to graph and the number of people involved in soccer was not in hundreds, it was the actual number. And the year was not after the year 2002, it was the actual year. Well, our graph, we'd have this thing that, let's see here. So if we had to have the year 2002 way over here, and then the number of people ultimately was what, 1280, we might need a huge piece of graph paper and nothing would show up in here because we wouldn't start until the year 2002. In other words, if we started from 0, 1, 2, 3, 4. So by doing sort of a time shift, we can say, well, this is going to be 2002, and then everything after that will be an increase of 1. So that we, again, so we don't have to have this huge graph. Is that making any sense? Sort of the motivation behind it. Another thing that they'll do, and I don't think it shows up in this assignment, but I think it showed up in a previous assignment. They'll have sort of a, I think there was like a Z-shaped thing to imply that the graph didn't start at 0, 0. It started like, maybe we could put 2002 here and 1500 there. That's another way of doing that. So again, just the motivation behind these kinds of things in hundreds or after a certain year are to make it easier to deal with the data when graphing especially. But be careful that you notice it because, for instance, you could get the right answer for part of these problems without doing it correctly, but your initial equation wouldn't be correct. In other words, if you completely ignore the N hundreds and the after year 2002, my point being, don't ignore the little details, okay? All right. Well, that's all I've got for you, unless you want further explanation on any of these examples, in which case I'm happy to do that.
Could you look at number 11?
Sure.
Yeah.
Number 11, okay. All right. So y depends on x. So we're going to have an equation that's going to be y equals mx plus b. Okay. Find the total cost of any amount of bulk candy at $1.58 per pound. So find the total cost of any quantity of bulk candy at $1.58 per pound. What does X stand for in this problem?
The number of pounds.
Right, good. Number of pounds. And no, that's not hashtag, that's number. All right, what does Y stand for?
The total cost per pound.
In what units would it most likely be?
Dollars.
Why do you say that?
Because it says 158, $1.58.
Right. Yep, good. So we got to look for clues here. So, oh, do you get any candy up front for free? So there is no starting value. It's just 0. So it would be y equals 1.58x. And what do our units look like? Well, it's y dollars equals $1.58. So that's dollars per pound times X pounds. Okay. So in other words, to get dollars, we have to have dollars over here. So our rate of change is dollars per pound times number of pounds. Pounds over pounds crosses out. Dollars equals dollars. Again, I'm just trying to show you how the units would all work out. So if they ask us what were the units on the rate, it would be dollars per pound. But this is going to be our equation. Okay, I'll just click on it there. Y equals 1.58x. See that? Yeah. And again, this has 0 as a vertical intercept. Now, if you could change it and you could say, well, a certain candy store would give out a free sample of 1 pound of candy to suck you in and then try and sell you the rest, You ever been to a Ghirardelli's store, chocolate store? They have them down in California. Usually as you walk in the door, they give you a little sample of a piece of chocolate. Yeah, get you sucked in so that you'll buy lots of chocolate. It usually works on me. Anyway, so that would be like that freebie stuff. But here, nope, no free samples ahead of time. All right, are we good with that one? Yeah. Any others you want to look at right now? Mike?
I missed one due to my technical difficulties. I missed that explanation. I'm very confused.
All right. And let's look at one. In fact, let's do a different number 1. So I'm going to go here and reset it. And is that different from number 1? Is that different numbers now? Yeah, it is. It is. Okay. So let's look at a different one. That way it'll be new to everybody. In a small community, soccer is the fastest growing summer sport. The number of people involved in soccer in hundreds from the year 2002 to 2013 is given by the equation y equals 0.6x plus 10, where x is the number of years after 2002. So I think most of the information is still the same, but what have we got here? Let's see. Our equation is y equals 0.6x plus 10. X equals the number of years after 2002. So x equals 0 in 2002, x equals 1 in 2003, x equals 2 in 2004, etc. Okay, you all right with that? Mike, are you okay with that?
Oh, my bad. I thought you wrote 2007 on there. That's 2002. Okay. A little confused.
You can't. Didn't you take the prerequisite hieroglyphics course before you take my class?
The hieroglyph?
Yeah,
oh,
you were
I missed that one.
Sorry. Yeah, that was a prereq. Sorry. Okay, so what is y? The number of people in hundreds. So y equals number of people in hundreds. Okay. So X is years after 2002. Y is number of people in hundreds. So there's all that extra information that's critical to the problem. All right. Use the equation above, which is this one, to complete the following ordered pair. So our input is 5. So our output is going to be 13. Okay. So there's the input and the output. You all right with that?
A little behind.
That's all right. I get paid the same whether I sit here or I rush through things. I get 2 cookies and a glass of milk at the end of the day. If I'm bad, I still get the 2 cookies, but they're stale and the milk is sour. Oh, well. All right, we good to go on?
Almost.
Almost.
So
Okay.
5. Where we get that? Oh, okay.
You good?
Yeah. I'm getting it.
All right.
I'm getting it. So,
What are you still confused about?
just adding. I'm adding stuff together right now. So that, boom. Let's see, plus 10. So that's okay.
Okay, we're good.
I'm just getting the information down.
You betcha. You betcha. All right. Part B says, write a sentence explaining the meaning of the answer. So what year would it be if we're 5 years into the future from 2002? So 2002 plus 5 would be 2000 what? 7. Okay. You following that, Mike? Where we got that?
Yeah, I'm catching up. I still putting everything together for the last one.
Okay.
For A.
We call this catch up with mayo.
Yep, catch up with mayo.
And some of you would probably relish the thought, while others of you saying, just let us alone. I know.
There you go.
I think I saw Courtney roll her eyes. That made it worth it.
Well, if you say a dad joke, someone's got to roll their eyes. It's necessary.
I am full of dad jokes. Full of something anyway. All right, so how many people were involved? What does the 13 represent? 13 100. So that would be 1,300. Let's see, we've got to look at that gets us. In 2007, there were 1,300 people involved in soccer. So basically, we're taking this ordered pair and applying this information. The fact that the 5 is years after 2002 and the 13 is in hundreds. So here we interpret it, what it actually means. Is that making sense? No?
No.
Okay, talk to me. Where am I losing you? All right, do you understand how the 5 becomes 2007?
5 becomes. No, I missed that part. Honestly,
Okay.
I missed that.
So the 5 is the X value, right? It's the first coordinate.
Okay.
And X is the number of years after 2002. So we've got the year 2002.
Got you. Okay,
Plus
that's what you were
5.
saying at the beginning. Yep.
2007. Okay.
So just okay. That's okay.
You're there. All right. The 13 is the Y value, and that's the number of people, but it's in hundreds. So 13 stands for 1,300.
So 18 in hundreds. Okay. So 8.
You got that?
Yeah. So if I have 8.5, it would be 850.
Yes. Is that what the next thing is?
Mine.
Oh,
yeah, that's
for yours.
where mine's
Okay.
different from yours.
Yeah. Okay. So on this one, 2016 would be what? 14 years later.
Mm-hmm.
So Y equals 0.6 times 14 plus 10, which would be what? 8.4 plus 10, or 18.4. So that's going to be 1,840. 1,840. Let's see here. All right. Now, I want to ask all of you a couple of different questions that weren't in this problem. How many people in this community were involved in soccer in the year 2002?
$10?
It's at 2002.
Here's my response to you there, Courtney.
1,000.
There you go. Good.
12.
Okay. Now, at what rate are the number of people increasing per year?
0.6.
No. I'll give you the same response I gave Courtney.
Oh. 600.
No.
With the 100 times the 0.6.
Okay. What's 100 times 0.6?
60.
60.
Yeah.
There you go. Okay, folks. Again, you got this extra information. So basically, in 2002, there were 1,000 people interested in or involved in soccer. and it was increasing at a rate of 60 people per year. But this doesn't tell us that unless we apply this piece of information and this piece of information. So you've got to grasp all of that extra stuff. And I know what you're thinking. You're struggling enough as it is just with what's here. And then we've got all this extra stuff. I feel your pain. I do. All righty. I will be back at 1:15 with an office hour. Should you have any questions, hopefully I've given you enough to just get you into trouble and hopefully get you out of it as well. All right, I'm going to go ahead and stop the recording.